name is Dustin Kendig. I'm from Microsanj, and we're here at European Microwave in Utrecht in 2025. And here we're showing a thermal imaging setup for a GaN HEMT. So here's a GaN transistor, and we're showing thermal reflectance measurements using UV light, so we can get down to 250 nanometer spatial resolution. And we can also do these pulsed thermal measurements down to 50 nanoseconds with 500 picoseconds with our fastest system. So after we get our pulsed thermal reflectance measurement, we can go into the analysis software and we can draw our line profiles to look at the peak channel temperature and do data analysis to look at temperature profiles or regions of interest. We can also use our thermal stage. So we have an integrated thermal stage with autofocus system using a piezoelectric stage to correct for alignment and thermal expansion, which is used for calibration when we're changing the temperature of the stage to known temperatures and measuring the reflectance versus temperature.
Hello, so I'm Martin Vanbrabant from Université catholique of Louvain, and today we are at European Microwave Week 2025 on Microsanj booth. And here we have the demo setup of our system. So as you can see, we have the infrared camera, and we also have some objectives for direct light, and this light use thermal reflectance. And we have the GaN transistors over there on the screen. We can see the temperature gradient over the sample, and we can identify the hotspot on this sample. And with this equipment, we can do transient measurements and really high resolution measurements compared to the traditional IR camera, which is kind of a benchmark.
Hello, my name is Dustin Kendig and I'm from Microsanj, and here we are at the MPI booth at European Microwave 2025. And here we are showing the integration of the Microsanj transient thermal imaging systems with the Microsanj and the TS2000 MPI automated prober. At Microsanj, we can supply a thermal image of parts down to 250 nanometer spatial resolution and 500 picosecond temporal resolution. And here we can have it integrated into a semi-automated prober, and then we can actually test and map the wafer and the temperature changes of the different parts and performance in a fully automated way.